Hi everyone, and thank you for joining us for our very first virtual field day at the Eastern Shore Iraq. I'm Helen Dowdy, Research Specialist in Entomology, and I'm going to go over some of the issues that we've been seeing this year with Colorado potato beetles and also in the past year, and discussing whether we are experiencing resistance or not. 2020 has certainly been a very rough year for everyone, and the early presence of Colorado potato beetle adults in commercial potato fields on the eastern shore certainly added to the challenges. In comparison to other years, we've seen adults come out later on in the season that have actually needed insecticide treatments, foliar, but this year there were a lot of adults present pre-bloom, which was very problematic. In some instances, the adults were seen even less than 30 days post at planting neonicotinoids. So the question, of course, is going to be, are we experiencing neonicotinoid resistance? And I will go over some of the studies we've conducted to try to answer some of the questions as to why we are seeing more adults early in the season. So for the past 2 years, in 2019 and 2020, we've been checking on the residual efficacy of planting neonicotinoids. But all the fields that were visited actually had only platinum 75 SG as an planting insecticide for the control of Colorado potato beetles. What we did is visit growers' field, collect foliage, and bring them back into the lab, place the foliage in petri dishes, and added Colorado potato beetle adults from non-treated fields at the Eastern Shore Iraq. And then we determined mortality up to 4 days after placing them in the petri dish. And in 2019, as you can see, any of the fields above 30 days after planting had between 60% and 80% of Colorado potato beetle adults surviving. Here, field 4 has 80% surviving adult Colorado potato beetles at 30 days after planting. And most of the other ones were very close to 100%. In 2020, we repeated these experiments, and similarly, a majority of Colorado potato beetle adults survived at a rate of 70 to 100%, and this is 19 to 69 days after planting and applications of platinum as the neonicotinoid of choice. What this chart shows is that we visited 14 fields on 2 different dates, May 8th and May 14th. The first lighter color bar represents the first collection date, and the second bar the later collection date. And for each field, I've indicated how many days after planting this represents. Field 1 and 2 were actually sprayed with a foliar before the second application. This is why they do not have any results for the second collection date. One field, field 14, even showed 80% survivorship of adult beetles as early as 19 days after planting. Looking at it in comparison to other fields, though, this particular field had 11 rain events or days out of 20 days between planting and foliage collection. So these results from 2019 and 2020 in the residual efficacy of thiamethoxam do not really actually give us a reflection of whether there is resistance or not. First of all, we're only testing one population of Colorado potato beetle, but they do give us some insight on what plays into residual efficacy of at planting neonicotinoids. And particularly how long one should expect for the insecticide to stay around and actually work in protecting against Colorado potato beetles. There are several factors that play into the breakdown of neonicotinoids early. Well, spring 2020 was very rainy and was very cold. An average of 3.98 inches of rain was recorded between March and May, and the average temperature during the time Colorado potato beetles began emerging was 59.7. This is all a combination of the third highest amount of rain in the second coldest month of April and May in the past 10 years. This certainly shows that rain events will play a large part in the residual presence of thiamethoxam in fields. 2020 was, however, a perfect combination to get presence of beetles early on in the fields. Fields were planted relatively late because of all the rain, and beetles were almost 2 weeks behind in being active in the fields, again, due to the very cold days that we were experiencing. So the beetles actually did not begin readily feeding until past the window of residual efficacy of thiamethoxam. Also, as can be seen through the studies indicated here on soil dissipation and leaching behavior of neonicotinoid insecticide thiamethoxam, in terms of precipitation, we do know that thiamethoxam, platinum, will experience leaching, particularly with heavy rainfall conditions or heavy rainfall events, as we may have experienced in the spring of 2020. So the take-home word on neonicotinoids resistance on the eastern shore is that there is no resistance yet. There may be a long-term natural drop in susceptibility over time, but the heavy presence of beetles that were not dying off in the fields this year in 2020 was primarily based on a combination of weather conditions and late planting dates. We had a lot of rain events, which meant faster leaching of the outplanting insecticide, with the combination of very cold temperatures, which meant later emergence and delayed activity of adult beetles, past the residual efficacy of the outplanting insecticide. So what about the diamides and in terms of resistance issues? Diamides are a class of chemical that contain the active ingredients chlorantraniliprole and cyanidraniliprole. They've been widely used on a variety of crops to control worms and certain beetles. They're labeled for soil and foliar use in potatoes for the control of Colorado potato beetles. A frequently used diamide in several crops, including potatoes, is beseech, which is a combination of the diamide chlorantraniliprole, same active ingredient as collagen, plus the pyrethroid warrior active ingredient lambda-cyhalothrin. So we're beginning to ask the question, are we seeing some diamide resistance in potato beetles? In 2019, there were some fields where growers had applied foliar collagen, and the beetles were still present after a while. Not feeding, but still present. In 2020, same thing. First generation adults were present in large number in a commercial potato field, pre-blooming during the time I was making visits to potato fields. The field was adjacent to a wheat field that was in potatoes the year prior. The beetles were present in such large number that the grower decided to apply Besiege, which contains the diamide chlorantraniliprole plus lambda-cyhalothrin at 9 fluid ounces per acre. 9 days later, the Colorado potato beetle adults were still observed live on the plants, as can see here. You can see some of the dead ones around the plant, but still we estimated that about 40% of the beetles had not died. So at this point, we decided, well, let's go ahead and investigate this situation a bit more and go ahead and determine whether we may be looking at some type of resistance for diamides. So here's the timeline of how we conducted some studies based on the population of Colorado potato beetles that did not completely die from the application of Besiege. The field was planted March 10th and platinum was applied at planting. 40 plus days later, the platinum had worn out, and the adult Colorado potato beetle started infesting the outside rows of the field pre-blooming. On May 11th, the grower applied Besiege at 9 fluid ounces per acre to control the adult beetles. 9 days later, we made a field visit, and several beetles were still alive. Again, somewhat is estimating about 40% of what was there prior. So from there, we conducted several bioassays. The first bioassay was conducted with beetles on May 20th that came from that particular field and were exposed to coragen, a diamide. Another bioassay was conducted on May 28th, again with the same population, looking at diamides as well as a variety of other labeled foliar insecticides. On June 3rd, in that particular field, the grower applied Agromeg to control the adult Colorado potato beetles that were remaining and were quite numerous. On June 9th, I collected egg masses from the field and returned them to the lab for hatching. And once hatched on June 18th, we conducted a third bioassay to see if there would be resistance shown on the first and second instar larvae that came from the population that did not die from diamide applications. So Bioassay 1 was conducted 9 to 10 days after the Besiege application in the field. There were several beetles still alive in the field, so I collected those, brought them back to the lab, placed them on foliage that was dipped in coragen at 7.5 fluid ounces per acre. So again, same active ingredient as Besiege. There were 5 adults per petri dish, 4 petri dishes per treatment, and we observed them for mortality. And it appeared that after several days of being exposed to the foliage that was treated with coragen, the beetles that did not originally die from the Besiege application in the field may have been originally stunned. This is recording % live, and for these assays, anything that is not considered live is either dead or intoxicated. So there was an initial stunning of the beetles, but then they kind of came back out, some of them came back out of it, to end with around 5 days with 44% of the beetles exposed to the Besiege field spray and the coragen dip assay still being alive. On the other hand, the other column indicates also that these beetles that were exposed to Besiege only were either 100% to 83% live. And as you can see from this image, they were actively feeding several days after they had been sprayed with Besiege. And here is some footage of the beetles surviving field exposure to Besiege 14 days after treatment, and the lab assay exposure to coragen 4 days after treatment. And another way to really tell that these beetles were alive is they were able to right themselves when turned over onto their back, which indicates that they were doing well and alive. So what can we conclude from Bioassay 1? Around 44% of adult first-generation Colorado potato beetles survived the diamide exposure in the field and in the bioassay. There was even some mating and egg laying that was observed. Feeding was limited, however, but not for those beetles that had recovered from the original field spray and were left to feed on untreated foliage. So should we conclude there is beginning of the resistance? The first bioassay warranted further investigation into this issue, with potato beetles not dying after application of diamides. So once again, we collected additional Colorado potato beetles from the commercial growers' field that had been exposed to besiege several days prior, and we tested them against several different diamides, being Minectopro, Exirel, and Besiege, as well as other insecticides that are labeled for foliar application of control for control of Colorado potato beetles. As a result, in Bioassay II, after 5 days after treatment, all beetles were dead in the treatments Agrumec, Blackhawk, Exirel, which is a diamide, Harventa, Minectopro, a diamide mixed with Agrumec. There were, however, 15% of the adults still alive in the besiege treatment. We also took a look at feeding, and feeding was pretty extensive in the untreated control, but everywhere else there was hardly any feeding, of course, because the beetles promptly died, or even in the besiege treatment, despite the fact that 15% still remain live after 5 days, feeding was significantly reduced. So conclusions from Bioassay II, 15% of the adult Colorado potato beetles again survived the besiege application, although a significantly lower rate than the first bioassay, which had 40% survivorship. However, the feeding was very limited in all of the treatments, including besiege. The good news is that Bioassay II demonstrated that there were several other insecticides that can help in controlling first-generation adults as foliar applications. So maybe further investigating was needed once again. So we decided to put together Bioassay III, looking at larvae control from the beetles that had survived besiege application potentially. We do know that adult potato beetles may not be feeding as regularly when they first appear. They are more concerned about mating. So maybe a true reflection of whether a population may be resistant would be to test the larvae which appear from the egg masses that had been laid. So again, I once again visited the field from the commercial grower that had where beetles had survived besiege application, and collected several egg masses, returned them into the lab, waiting for them to hatch, and I used the first and second instar larvae to place them on potato foliage that was dipped in field rate concentration of insecticides. This time we looked at Minectopro, again, which is a diamide, with the Agrumec, Exirel, and Besiege. And the results showed that all treatments had 0% surviving CPB larvae and 0% feeding 4 days after treatment, in comparison to the untreated, which had 100% live larvae at 4 days after treatment and 65% feeding in the untreated. So conclusion from Bioassay III, and are we really still talking about diamide resistance that may have occurred? All the larvae in that particular bioassay did not survive diamide exposure or exposure to Agrumec. However, emerging adults that were collected from the commercial fields in Bioassay I and Bioassay II may have been showing early signs of resistance to diamides. Further investigation and monitoring is really needed, as we cannot say undeniably that there is diamide resistance. Also, would it be maybe beneficial to hold early sprays of Colorado potato beetle adults and target larvae instead to prevent rapid resistance? Thank you for listening, and if you have any questions, please do not hesitate to contact us at the following emails and numbers. Thank you.